Hello everyone, this is Pritika Patel working as an assistant professor in Computer Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center Navsari, which is affiliated by GTU and AICT. Today in this session we are going to discuss about ADT, that is Abstract Data Type, which is the topic of Subject Data Structure of second year third semester. Now, first of all, we are going to discuss about what is data type. Data type is the common, basic and the most common classification of data. By using it, compiler gets to know the form or the type of information that will be used throughout the code. So, basically data type is a type of information transmitted between the programmer and the compiler, where the programmer informs the compiler about what type of data is to be stored and also tells how much space it requires in the memory. Some basic examples are integer, string, etc. It is the type of any variable used in the code. Now, next is abstract data type, that is ADT. An abstract data type is a data type whose representation is in hidden form and of no concern the application code. Here, example of ADT is given. We have a reservation system. In this system, we can book or reserve our seat, determine available seats, cancel a reservation, etc. But we don't know what actual data and operation perform behind this system, that is called abstract data type. So it is just like black box testing. We can say that ADT is a mathematical model with collection of data and operations defined on that model. See, here in this figure we can see that ADT is nothing but collection of data and operation performed on that model. Now, next point is stack ADT. In stack ADT, implementation, instead of data stored in each node, the pointer to data is stored. Means in stack ADT, basically pointer on which data stored is considered instead of data stored in particular node. The program allocated memory for the data and address is passed to the stack ADT. Here in this figure, conceptual view of stack is just like this. In that we can insert the element, delete the element, this type of operations we can perform. But in physical structure, stack have count and top pointer. Count and top pointer for number of entries currently in stack. How many numbers of elements are currently present in stack, that is pointed by counter and top, and stack max for maximum, or we can say that store total number of element. Okay, so this physical structure is hidden from us. We can only see this conceptual structure, that is called stack ADT. Now, operations performed on stack ADT. Basically, all operations we can perform on stack from single end, that is top of the stack. Same way in stack ADT, we can perform all the operations from top of the stack. So following operations are there. First is push operation. It is used to insert an element at one end of the stack called top. Then next is pop operation. It is used to remove and return the element at the top of the stack if it is not empty. Then next is size operation. It returns the number of element into the stack. The next operation is empty. It returns true if the stack is empty, otherwise it returns false. Then is full function. It returns true if the stack is full, otherwise it returns false. So these are the operations which we can perform on stack ADT. Now next is queue ADT. Queue ADT follows the basic design of stack. Queue operations take place at both ends. Insertion is done at the rear and deletion is done at the front. Here in this figure, conceptual view of queue is just like this. In that, we can insert the element from rear and delete the element from front. But in physical structure, you have counter, then counter pointer for number of entries currently in queue. Max size is for to store total number of element. Then front pointer is for delete the element and rear pointer is for insert a element. So this physical structure is hidden from us. We can only see this conceptual view, or we can say that conceptual structure. So that is called queue ADT. Now operations performed on queue ADT. First one is NQ operation. It is just like insertion operation. NQ operation is used to insert an element at the end of the queue, because in queue we can insert element from rear. Then next is DQ operation. It is just like delete operation. It is used to remove and return the first element of the queue if the queue is not empty. Then next is size operation. It returns the number of element in the queue. Then next is empty operation. It returns true if the queue is empty, otherwise it returns false. Then next is full operation. It returns true if the queue is full, otherwise it returns false. So these all are the operations which we can perform on queue ADT. Now next is list ADT. In list ADT, data is generally stored in key sequence in list, which has a head structure consisting of count, pointers and address of compare functions needed to compare the data in the list. Here in this figure, list having count, compare and node to store data and store address of next element, that is physical view. And in conceptual view, list have number of nodes which have two parts, that is data and link part. Data part is used to store the data and link part is store the address of next node. Okay, so we can only see this conceptual view only, so it is called list ADT. Now operations performed on list ADT, that is first one is get. It returns an element from the list at any given position. Next is insert. Insert an element at any position of the list. At that time we can use insert function. The next operation is remove. It removes the first occurrence of any element from a non-empty list. Next is replace. To replace an element at any position by another element. At that time we can use replace function, or we can say that replace operation we are going to use. Then next is size operation. It returns the number of element in the list. Next is empty. It returns true if the list is empty, otherwise it returns false. Next is full function. It returns true if the list is full, otherwise it returns false. Now next point is difference between primitive and non-primitive data structure. It is the most important topic for GTU exam as well as mid exam. So we can discuss about primitive data structure and non-primitive data structure. Primitive data structure is a basic data structure and directly operated by machine instruction, whereas a non-primitive data structure is derived from primitive data structure. Now next is examples of primitive data structure are integer, character, float, pointer, etc. Whereas in non-primitive data structures examples are array, list, file, etc. Now next difference is difference between linear and non-linear data structure, which is also most important for GTU exam as well as mid exam. Okay, so from this point of view we are going to discuss this difference between linear and non-linear data structure. Linear data structure are a data structure in which data are arranged in linear sequence, whereas in non-linear data structure data are not arranged in sequence. In linear data structure, every element is related to its previous and next element. In non-linear data structure, every element is related to many other elements. In linear data structure, data item can traverse in single run. We can traverse all elements of linear data structure by single run. Whereas in non-linear data structure, data can't be traversed in single run because it is related to more than one element. Then next point is implementation of linear data structure is easy, whereas non-linear data structure implementation is not easy, so it is tough. Then example of linear data structure is array, stack, queue, linked list. Whereas examples of non-linear data structure are tree and graph. Thank you.